is past. Yes.
Yep. You're good.
And can you see my slide, right?
Yeah.
Yes.
Okay. Today I am going to talk about rapid and efficient degradation of organic content by catalytic oxidation using copper system in nanoparticles. I am a PhD candidate here at University of Texas at Arlington. First of all, I would like to discuss the importance of water. As we all know, life is impossible without water. We need water for various purposes. We need water for drinking, cooking, washing, and so on and so forth. But the sad news is that by 2025, more than 1/3 of humans will live in areas with insufficient supply of fresh water for drinking and irrigation. So we need to save water in order to save our life. There are many causes of water pollution. One of them is the excessive use of pesticides. Even though the use of pesticides has enhanced crop production, pesticides are a major source of pollution for water. Another cause of water pollution is the use of organic dyes. Organic dyes are used in various industries such as food, textile, plastic, cosmetic, paper and pulp industry, and so on and so forth. These organic content are very harmful for all living beings because they are non-biodegradable and they have high toxicity. As a result, the degradation of organic pollution has been a matter of considerable interest among researchers. Various methods have been used for water purification. Among them, advanced oxidation process has gained a great attention among researchers in recent years. What is advanced oxidation process? Advanced oxidation process is an innovative method which degrades organic pollutant using reactive oxygen species, mainly hydroxyl radicals, but there could be other type of radical as well, but the main is hydroxyl radical. When hydroxyl radical reacts with organic compounds degrades into non-toxic carbon dioxide and water. Various homogeneous and heterogeneous materials have been used in wastewater treatment, but here we are interested in copper cysteamine nanoparticles. This is a new nanoparticles that was invented by our lab in 2014. These nanoparticles can be excited by UV light, microwave, X-rays, and ultrasound, so that our nanoparticles is suitable for superficial and deep cancers because UV light can penetrate about 1 millimeter, microwave can penetrate about 2 centimeter, but it depends upon types of tissue and frequency of microwave. X-rays have limitless penetration, while ultrasound can penetrate about 15 centimeter, but it also depends on frequency and types of tissue. So our nanoparticles is suitable for superficial and deep cancers. From our several previous work, we found that our nanoparticle is an effective reactive oxygen species producing agent for killing cancers and bacteria cells. Those results motivated us to examine the performance of our nanoparticles for the destruction of water toxins by reactive oxygen species. We believe that our nanoparticles would be an efficient heterogeneous phenol-like catalyst. Our nanoparticles contains copper, but the oxidation state of copper in our nanoparticle is 1+. The reaction rate of Cu1+ is about 160 times higher than Fe 2 plus. So we would think that our nanoparticles would be better than iron-based nanoparticles. Furthermore, the reaction rate of Cu1 plus is about 22 times higher than that of Cu2 plus. So we believe that our nanoparticles would be a promising candidate for wastewater treatment rather than Cu2 based materials. Now I would like to show some of my result. First, comparison of degradation activity of CuCy with copper chloride on rhodamine B. Rhodamine B is a dye extensively used in textile industry. Rhodamine B has a pink color, but with our nanoparticle, it started losing its color and it completely lost color within 15 minutes. However, we did not see any noticeable change in physical color of rhodamine B using copper chloride. For the purpose of quantification, we measure the absorption spectra of respective samples. In this graph, y-axis shows degradation in percentage and x-axis shows reaction time. This is our nanoparticle and this is with copper chloride. Here we used 1.32 millimolar our nanoparticles and 3.96 millimolar copper chloride because each molecule of C contains 3 atoms of copper. So to make the copper concentration same, we use 3.96 millimolar. I have a table here. From this table,
Just 2 minutes left. Yes.
okay. From this table, we can say that CuCy caused about 99% degradation rhodamine B within 15 minutes, but copper chloride caused about 16%. We confirmed the production of hydroxide radical by using photoluminescence technique. In this method, increase in photoluminescence means hydroxide radical production. As you can see here, CuCy in the presence of hydrogen peroxide produce significant amount of hydroxide radical as compared to H2O2 alone, CuCy alone and DI water alone, which means that the reaction system can produce hydroxide radical. We further confirmed the production of hydroxide radical by using another method. In that method, we used methanol, which is a well-known hydroxide radical quencher. This is without methanol. This is with 14.8 millimolar methanol. This is 74 millimolar and this is 370 millimolar methanol. I have a table here. From this table, we can say that while increasing the concentration of methanol, the degradation of rhodamine B is significantly reduced, which means that the hydroxide radicals are produced in the system. We also compared the degradation activity of CuCy with copper chloride on methylene blue. Methylene blue is also a dye extensively used in textile industry. It has blue color. With CuCy, it lost its color within 6 minutes, while copper chloride did not change the color noticeably. For the purpose of quantification, we measure absorption. I have a table. From this table, we can say that CuCy caused about 100% degradation of methylene blue within 15 minutes, while copper chloride caused about 21%. This is because our nanoparticles contains the copper having oxidation state +1, but CuCl2 contains oxidation state 2. The reaction rate of Cu1 plus is about 22 times higher than Cu2 plus. That's why our nanoparticles showed better performance. More importantly, our nanoparticles can be reused, but copper chloride cannot be. Now I would like to conclude my presentation. Our nanoparticle with the help of hydrogen peroxide can cause oxidative degradation of organic pollutant. CuCy is better than copper chloride for water purification. We anticipate that our nanoparticles could be an effective and economic catalyst ideal for treatment of toxic organic pollutant in water. These are references. Thank you for your attention. Any question?
So good timing. So we have 1 minute about for any questions. Please ask your question. Unmute and any question here?
It's good talk though. I have two questions. Quick. The first one is you use a methanol to quench the hydrogen peroxide, right?
No, no, no.
Sorry, reaction oxygen. Yeah,
This
right.
is the hydroxide radical quencher. Methanol,
Quencher.
ethanol, DMSO. Yeah.
So how do you get from you jump from 74 to 370 nanomolar? How you titrating that nanomolar? Like why not 100 nanomolar? Why not in between? You're just jumping three different nanomolar. Is there any reason like what? Did you test in between like is there a optimal between 370 to 74? Why? Because the
No, very good questions. I haven't done that, and I have planned to do that because this is just the beginning of detailed investigation. Yes, yeah, very good question. Yes.
that like methanol is still very toxic. And then the second question is hydrogen peroxide. I think as far as I know, it itself is oxidative. It also causes the reactive oxygen. It causes like it also produces hydroxide group. Do you have,
Yes.
do you have any
So,
idea like why do you combine with copper? Because as a hydrogen peroxide, as far as I know, it also produces some radical these reactive oxygen species ROS, what we call. But you are
yes,
combining with copper. Does that mean you're enhancing or what is why?
because hydrogen peroxide is also oxidizing agent. Later, we have the problem to use UV light, sunlight. But for now, we have used hydrogen peroxide. Yes, hydrogen peroxide is still producing some ROS, but which is very less than that of the combination with UCI.
Anyway, I think your voice is
Kamal
very
sir,
okay. Thank you.
Kamal sir, I just, Kamal sir.
Hello. Yes. Azure.
So there is a very huge echo going on. So I don't know which mic is causing this issue. So when
Looks like
the
it.
yeah, so I think it should be either Kamal sir's or maybe Krishna sir's microphone. I don't know. When I turn off mine, it's still the echo is going on.
Any question? Hello?
Krishna
Krishnaji,
sir, we cannot
you
hear
on.
you.
Sorry. uh, so thank you, Jose. A very good talk. So we are moving ahead. Our next talk is from Manoj Kumar Chaudhary from Central Department of Physics. He's talking about structural, spectroscopic, and physicochemical properties of ricobenzidole from experimental and computational approaches. So yeah, the talk will be played and you get ready for questions, I guess.
Okay, sir. Okay.
Amalji, yes.
Krishnaji,
Sir,
Krishna sir, do you have a
sir,
video?
are you going to play my video, sir?
So Kamalji, are you playing or yeah?
I don't have a video. I have to look at. I can make you result.
Okay, let's see.
You go ahead and play the video.
Yeah. So do you listen this now?
Yeah, but it's not share on the screen.
Here,
Oh wait.
screen share.
Screen share.
Wait a second. Yeah, I have to go here. Share with optimize. So is it ready now? Do you listen?
We cannot see the screen.
Well, it did work last time. Stop my video.
If not, I'll try from my inside. Try you
Okay,
first.
it did work last time like that, yeah. I can read if you want.
It's not working from there.
After you share your screen, you might have to click the screen one or something to display.
So, go here.
Yes, share content. Then I think you have to select the screen, one of the tabs among many.
Okay.
Yeah.
Coming now?
Yeah.
Yep.
Yeah.
Okay. Great.
My research under the Dr. Joshi, Department of Physics, Sidhans Campus, University, Nepal, and Professor Poonam Tandon, Department of Physics, University of Lucknow, India. I am going to present my research regarding to structural spectroscopic IRNMN, physicochemical properties of carbon from experimental and computational modes. These are the outlines of my presentation. This is the 2D figure of ricobenzole with molecular formula C12S15N3O3S, which is active metabolite of albendazole, which is also albendazole sulfoxide, lies in the benzimidazole group of drug, which is used to treat parasitic disease in humans and animals. This is effective in controlling the gastrointestinal infection caused by roundworm and tapeworm. Many experimental and theoretical work has been performed to enhance the potential of drug, but quantum chemical calculation analysis like structural spectroscopy, physicochemical properties of ricobenzole has not been performed. That's why I am interested about this. These are the software that I have used for my research. Gaussian 09 is used for the density functional theory calculation by using the functional B3LYP with the help of basis set 6311 plus GDP. Gauss V05 is used for the visualization purpose. GADU 2PD is used to find the modes of vibration by using the Poulet recommendation. AIM 2000, AIM all software is used to study the intramolecular hydrogen bonding on the basis of quantum theory of atoms in molecule. Autodoc Code and Discovery Studio Visualizer is used to Today I am going to focus about these works. This is the one-dimensional potential surface scheme to find the stable structure of the molecule. This is the molecular electrostatic potential to study the distribution of charge around the molecule in space. This is the comparative study between the experimental and simulated spectra. And this is the molecular docking. Mapping with a conformer 1, then it is found that the benzene as well as the imidazole ring are in the same plane along with this methyl group, but this methyl group are slightly tilted, which is not in the same plane. To study the stability of the molecule, hyperconjugative interaction energy has been studied on the basis of natural bone orbital analysis, and if the stabilization energy is more, then interaction between the filled orbital to the vacant orbital is intensive and vice versa. And from this it is found that the transition from the filled orbital to the vacant orbital from the lone pair N7 to the antibonding pi orbital O4C18 is highest, that is equal to 61.96 kilocalorie per mole, and this contribute the molecule more for the stability. And moreover, the transition of electron from the N5 lone pair to the antibonding N6 C16 also contribute 55.06 kilocalorie per mole. So this transition also contribute more for the stability of the molecule. This is the molecular electrostatic potential phase, which discuss about the distribution of charge based on the molecule, and if the red region, then there is the more electronegative potential. If there is the blue region, there is the more electropositive potential. If there is the green region, then there is zero electrostatic potential. And from this study, it is found that this has the more electropositive potential, as that is the blue region, and this group is the more electronegative potential, as there is the red region. And in the molecular system, the HOMO and LUMO orbitals is the main orbital that takes part in the chemical reaction. And if the energy gap between HOMO and LUMO is least, then the molecule is least stable and more chemically reactive. And if the energy gap is more, then the molecule is more stable and least chemically reactive. And here the conformer 1 is the more stable in comparison to conformer 3, as it has the least conformer 3 has the least binding energy in comparison to conformer 1. Also, which particular atom in the molecule is more chemically reactive? For this purpose, the local reactivity descriptor is the fundamental tool. This is studied on the basis of Hurst-Field charge analysis, and which is measured in the terms of foci function. If the value of foci function is high, then that particular atom is more likely to participate in the chemical reaction, either for the electrophilic attack or for the nucleophilic attack. And here the C12 atom in ricobendazole has the highest FK minus, so this is more electrophilic region, and whereas O2 has the highest FK plus, so this is the more nucleophilic region. We study the intramolecular hydrogen bonding in the molecule. Quantum theory atoms in molecule has been studied. And in this case, it is found that there are two intramolecular hydrogen bonding. One is between O4 and S26, another is between O2 and S22. And if the interaction energy is more, then the interaction is intense. If the interaction energy is least, then the interaction is weak. And from this study, it is found that the interaction energy is more for the O4S26. So this is the strong interaction in comparison to O2S22. And if the Laplacian of electron density is more than 0 and total electron energy kinetic energy density is less than 0, then interaction is medium in nature, as given by the Rosa et al. So these two interactions are medium in nature. This molecule has 34 atoms, so altogether 96 modes of vibration has been obtained from the relation 3n minus, and all the IR and actives, and this is the signature of this is the signature of CS stretching. This is the signature for the carbonyl group stretching, and this is the signature for the CC stretching of the ring R1. And from this study, it is found that the signature of experimental is well matched with the signature of the simulated spectra. And similarly, this is the FT Raman, and this is the signature for the CH stretching. This is the signature for the carbonyl group, and they are in the good agreement with the experimental, and between the theoretical and experimental. And this is the stretching for the sulfinyl group, and all the signatures are in the good agreement with the theoretical and experimental spectra. And as the temperature increases, then entropy, enthalpy, and specific capacity of the molecular system increases. And this is the correlation graph between entropy, enthalpy, and specific capacity, and their values increases with rising temperature. To be a good candidate of drop tool in which the molar refractivity should be in the order of 40 to 130, molecular weight should be in the range 180 to 500, and the number of atoms between 20 to 70. And all these criteria is followed by the ricobendazole, so this can be taken as a drug. This is the molecular doc. Swiss target prediction has been taken into consideration to predict the target, and 3 protein has been taken into consideration, and they shows the good binding, and the binding sites is generally found to be S26 and S31. And this is the ligand efficiency, this is the binding energy, and this shows the good binding interaction with the highest binding energy, 8.07 kilocalorie per mole. These are the conclusions. Sulfonyl group is most negative electrostatic potential. N7S31 shows the most positive electrostatic potential. Conformer 1 is harder, and conformer 3 is more chemically reactive. The most reactive site for electrophilic attacks are O2, and nucleophilic attack and free radical attacks are C12 and S1 respectively. 2 intramolecular hydrogen bonding, S22O2 and S26O4 are formed, and they are medium in nature, and the active binding sites are S26 and S30. These are the references. I would like to acknowledge my supervisor, Dr. Bhavani Datta Joshi, and Professor Poonam Tandon for good support, and Dr. Vinil Arial, head of Central Department of Physics, and all CDP family. And I would also like to acknowledge faculty of physics on campus and all Amit campus family and lab members of Macromolecular Lab, Lucknow, India. I also like to acknowledge CCS TDS for providing financial support, and all my family members and well-wishers. Thank you, sir. Any questions, suggestions?
I'm Neil Pandey. I have a quick question. Your conclusion is free radical attacks copper, right? C12.
C12, yes, sir. Free radical attack.
Do you have any reason why free radical attack the copper?
There is no copper, so there is carbon, sir.
Carbon, yes, carbon.
Currently, I have no idea about that.
Yeah, for oxygen you have lone pair. Yeah, it's okay. Okay, that's it. We cannot hear Krishna sir.
Unmuted.
Yeah.
We can ask more questions if we have.
Sure.
Thank you, Manoj. It's a very good talk. So I think we'll move to talk, and any question we can ask you. Use chat here. Also, we can use. Our next talk is from VK from Chemistry campus, Trivandrum University. Let me play the talk.
Hello, namaste. Greetings.
Sorry, this one. So, what's giving me trouble all the time.
You can myself.
Yeah, let's go this one. Oh, this one is problem, I guess. Okay, let me close and again try it.
It's not responding.
Let me retry.
Okay.
So content. Do you see anything now?
Yeah, it says it's starting sharing content.
Okay, let's see. Yeah, it's hanging. There's some problem there.
So let me try then from my side.
Okay, yeah, maybe we do that. Yeah. This stuff, yeah, it's hanging here. Yeah. Frozen. हजुर यो frozen भइरहेको छ यो.
Next person is Ankit Bikra.
Yes.
Yeah, let me try then.
Yes.
Did you see my screen?
No, my screen is frozen. I don't know.
Yeah, we can see you. Yes, we can see.
Good.
All right, let me play with the.
Yeah, it's.
Krishna sir, you can unmute yourself.
Yeah, it's good.
Okay.
Please unmute everyone. Background noise. I don't know where it's coming from.
Yeah, my computer is frozen.
Mute yourself. Everybody mute yourself.
My name is Ankit Bikra. I did my bachelor's in science with a chemistry major from Trivandrum University affiliated to UNAN campus, Nepal. This is an interesting event here. I appreciate your passion for your presence here through the virtual platform. May I have a permission to start the presentation? The title for my presentation is Analysis of the content in selected vegetarian food items in. So these are the content items. Basically, but its deficiency in the body is very common. The adult body contains approximately 4 iron. It is obtained from meat, nutrition, food, and vegetables. Iron is a component present in the species. It conveys oxygen throughout the body. Without iron, the body cannot make metabolism. Thus, it is an essential micronutrient. Vegetarians are more susceptible as they consume non-heme iron, which needs to be altered before it can be absorbed by the body. Deficiency of iron in pregnant women, lesbians, and those at the menstrual stage are in high risk. This group of people are aware of iron intake. In general, we have general and specific objectives. Where is general objective? The objective of the study was to analyze content in various samples. To analyze iron in various vegetables, spices, and in proteins and grains was the specific objective of our study. Common methods for iron titration, atomic absorption spectroscopy, UV spectroscopy. Where titration is here, potassium hyacinate to analyze the iron in samples. Atomic absorption spectroscopy, or AAS, wavelength can be ranged from 8.3 nanometer or 7 nanometer. UVB spectrophotometer when ranged from 350 to 1200 nanometer, and potassium thiocyanate AFM can be used as reagent. In our study, we used UV-based spectrophotometer as it can be used to do qualitative and quantitative analysis of organic and inorganic compounds, and it is based on Beer-Lambert law. Beer-law states absorbance is directly proportional to concentration of analyzed light, while Lambert law states absorbance is directly proportional to path length. We use UV-based spectrophotometer of 2,300 our one campus with an anchor. While discussing the monochromatic light by the source, the light with sample in cubic light is either the transmitted light is measured with detector, the absorbance is displayed without detector. The advantages of low cost of operation, easy to handle, and it provides list of reagents study are dilute hydrochloric potassium dichromate and ferric acid. Before adding potassium, the sample is yellow in color in test tube, and after adding potassium thiocyanate, the sample which was previously later changed in now preparation of acid. You can see before you can see was and that of 2M hydrochloric acid was added, and it was then HML was treated with 5 ml sample with a calcium. The absorbance was mixture of synthesis was used as in procedure. Potassium to determine the to derive calibration plot run and concentration determined by substitution absorbance value in calibration equation. After adding potassium, categorized 10 samples and given this one just to S5, S6, S7, S8, 9, respectively. Where indicate in high amount and the and light color is around 4. Get a straight line. I square correlation between the data analysis similarly, then also has given material and analyze while talking about result summary, above graph samples taken from the dots indicate the range above +1 -2 respectively. The graph shows that found in sample B above dots is found in sample G as the range is large. So the content is found to be maximum in sample B, and the iron content minimum in sample D. Among spices, most contain most iron metals. Now, limitation we were focused on only those spices conversions we will resolve to result single instrument that is so the conclusion of our samples highest quantity of iron available in sets was the least iron was available in chrome. Following people. Thank you.
This is something already. कृष्णजी
हजुर मेरो यो कम्प्युटर फ्रोजन भयो के भयो यो अर्को कम्प्युटर गर्न खोजेको प्रब्लम पारिदियो अनि सुन्नु भएको छ मलाई हजुर
I think there is some noise. I don't know where is it coming from.
Right.
The background.
So यो
कमलजी त्यो नोइज चाहिँ तपाईँकोबाट आइरहेको छ
I mean, I haven't done anything else here in my room. So, do you guys have any idea what should I do?
So मेरोमा चाहिँ त्यति साउन्ड आएन म बोलेको सुन्नु भएको छ हजुरहरूले
सुनिया छ
ए हजुर अनि त्यसै मेरो कम्प्युटर यहाँ फ्रोजन भएर प्रब्लम पार्दै सरी इन्कन्भिनियन्स आई ट्राई टु ओपन द अदर कम्प्युटर अल्सो कज ट्रबल thank you Ankit ji good talk so let's ask some questions so if we don't have any questions let's go to another talk from Rajendra Prasad Koirala Central Department of Physics, PhD candidate there, is talking about repair mechanism of methylation in DNA transferring methyl adduct to O6 alkyl guanine DNA alkyl transferase protein. Kamalji, could you play this one? Yeah, my computer is frozen.
Okay. So let me share my screen.
Respected chair. Now I am here to present our methylation in DNA.
कमलजी तपाईँले म्युट गर्न ट्राई गर्नुहोस् त
मलाई होस्ट बनाइदिनुहोस् त म यहाँबाट मैले त्यो डाउनलोड गरेर मैले यहाँबाट गरिदिन्छु मेरोबाट आउनु पनि
Okay, okay.
प्ले गरिदिन्छु
Okay, so मलाई मैले होस्ट बनाइदिएँ भनेको
निल पाण्डे
हाम्रो निलजीलाई
मेरोबाट तपाईँले बन्द गर्नुहोस् हुन्छ कस्तो हुन्छ सुन है त
मेरो अप्सनै छैन किन
तपाईँले ठिकै छ
चेन्ज प्रेजेन्टर भन्ने तिम्रो अप्सन
प्लिज जस्ट म्युट अल एभ्रीवन के सबैले म्युट गर्छ
हैन मैले म्युट गरिसकेको छु यो चाहिँ कामबाट हालेर मैले म्युट गर्दा पनि मैले म्युट
मेरो कम्प्युटर फ्रोजन भएको छ म चाहिँ डिस्कनेक्ट गरेर रिस्टार्ट गरे अनि हुन्छ कि अब ठिक हो
मेरो तपाईले हुनुस् त मैले मेरोमा कस्तो हुन्छ मलाई होस्ट नबनाए पनि हुन्छ होला नोइज आएन भने त भयो नि
Respected chair, first of all, I would like to thank ANPA team for providing this
अहिले त नोइज आएको छैन नि त इट इज गुड
pandemic situation. Now I am here to present a part of my research work entitled Repeated Mechanism of Methylation in DNA, Transferring Methyl Adduct to O6 alkyl guanine DNA alkyl transferase AGT. Me, Rajendra Prasad Koirala, Central Department of Physics, Tribhuvan University, Nepal, currently PhD student. These are the outlines of my presentation. In the beginning, I would like to introduce what the problem of my research work is. In next step, I will explain about 3 molecular systems we prepare to handle the research problem and method of molecular dynamic simulation. Then results and discussions will be explained. Likewise, conclusion of the study, acknowledgement and references. There are several types of DNA damages in living organisms. Some of them are mentioned below. Our work is basically focused on DNA damage and its repair mechanism. In ordinary condition, adenine of one DNA strand links to thymine of another strand with 2 hydrogen bonds, and cytosine of one DNA strand links to guanine of another strand with 3 hydrogen bonds. However, DNA bases sometimes wrongly link as shown in figure below. Let me show with point. Upper one link. This link shows the inter-strand link, and lower one link. This shows the intra-strand link. Similarly, DNA backbone may be broken. Single break means single strand break, and it is double break means double strand DNA. DNA may be damaged by additional chemical fragments like attachment of methyl at an atomic point in DNA nucleotide. Here methyl adduct CH3 is attached to O6 position of guanine. This is our target. This part explains how DNA methylation at O6 position of guanine occurs. Figure 1, this one, figure 1 represents the nitrogen base part of guanine. If a methyl adduct CH3 is attached in O6 point of normal guanine, guanine cytosine pair can be mutated to adenosine thymine pair. During methylation, N1 of guanine, this is the N1 point, is deprotonated and forms double bond to C6, like this double bond. This affects the conversion of double bond to single bond between C6 and O6. It's a single bond. It converts to single bond. Finally, methyl adduct finds the space to attach at O6. This is methyl. Our goal is to transfer methyl adduct CH3 from DNA to AGD protein, as shown in figure displayed. This is methyl guanine. It is normal cysteine. Now we want to transfer this CH3 to cysteine, and guanine becomes normal guanine after transferring this methylation fragment to cysteine, methyl cysteine. Now the major effects of methyl damage in DNA are here. The major effect is the genetic disorder and problem in gene expression, which may cause cancer. The advantage of this research is the biomolecular prediction of drugs for genetic diseases. This work is concerned with application of physics on human health. Here are two pictures showing genetic diseases. To achieve our goal, we prepared three different molecular systems. Molecular structures we have taken from PDB ID 1T38.pdb and 1T39.pdb. These PDB IDs are taken from rchp.org, system 1. It possesses the methylation fragment at the O6 point of guanine and normal protein AGT. This is complex 1 and it is taken from 1T38.pdb. System 2. It contains the covalent link of cysteine at ERC with methylation point CL3 of guanine. It is complex 2 and it is taken from PDB ID 1T39.pdb. System 3. It contains normal DNA and methyl AGT at cysteine. It is complex 3 and is modified from PDB ID 1T38.pdb. This complex 1 structure contains the methylation at this O6 position. This second complex has the covalent link between guanine and cysteine. Complex 3 contains the methylated cysteine and this guanine is free from the methylation. Out of these systems, I explained first about the formation of covalent link between DNA and protein and its stability. Here figure A shows this. Figure A shows the complete structure of complex 2 and structure B shows, this structure shows the targeted part of covalent link. There is the covalent link, our targeted part. Here sulfur atom of cysteine side chain is covalently linked to methyl group of guanine in DNA. 100 nanosecond NVT simulation was performed to find the stability of covalent bond between protein and DNA. Our pre-assumption is that if it is possible, it can be applied in therapeutic goals. After calculation, we conclude that catalytic site of covalent bonded state of DNA AGT complex may provide a novel target for clinical drug screening. To investigate the possibility of methyl transfer mechanism, we performed umbrella sampling simulation in order to find free energy in two situations. For the free energy calculation, DNA is translated along negative x direction so that the sample windows can be selected in each 1 angstrom distance apart. Free energy is calculated of each sample and a continuous graph is produced from weighted histogram analysis method, WAM. This process was done for complex 1 and complex 3. First figure shows, this one is the first figure, shows the free energy curve for complex 1, in which methylation damage is at in DNA. Second figure, this figure shows the free energy curve for complex 3, in which methyl damage is present in AGT protein. Del G1 and del G2 are change of free energy for the corresponding situations. Now, free energy change has been compared to estimate the binding affinity between DNA and protein. The black curve, this curve shows the free energy of complex 1. Red curve, this curve shows the free energy of complex 3. Analyzing the graph, free energy change of non-covalent bonding system at which methyl adduct was at DNA is approximately 11.0208 kilocalorie per mole. Free energy change of non-covalent bonding system after methyl transfer to AGT is approximately 9.83 kilocalorie per mole. This shows the methyl transfer is possible and AGT can be anti-cancer drug. Now the brief conclusion. Existence of covalent linkage of methyl DNA and DNA repair protein AGT is possible and can be a future target for drug designing. The free energy change of molecular complex of methyl DNA and AGT is greater than that of DNA and methyl AGT. This shows the possible transformation of methyl damage from DNA to protein. AGT can be a strong candidate to relieve methyl damage from DNA and can be used as the therapeutic purpose of proposed to remove the methyl damage in DNA. This work can be of future avenues for DNA and protein interactions. These are the acknowledgements. These are references. Thank you.
Thank you. I am ready here.
Thank you, Ramzi. Good talk. So I had a little problem and I had to reboot my computer. I couldn't listen at the beginning. So I hope it went okay for everyone. Sorry from my side, is the computer frozen? Now let's ask questions to Ramzi.
If there is nobody else, I can go ahead and ask one question.
Yeah.
Go ahead.
Okay, Rajendra, that is really nice presentation. It's
Thank you.
nice to see you here. Okay, I'm Kamal.
Yeah.
Probably you know very me.
Yeah. Okay.
Right. So one quick question is, like you see the graph that when the complex I and complex II forms, you show the minimum free energy at almost at the same angstrom. Is that?
Yeah.
I think I can play back, right? So what your one graph shows is that the free energy is minimum around 28 angstrom.
Actually, Kamalji, I could not get.
Okay, let me see what it.
Yeah.
Neil, yeah. So that graph at the very last.
Yeah. The graph for complex 3 is slightly towards the right hand side. The minimum pitfall is slightly right hand side. At the beginning, there is the almost equal forces we find there. We have calculated also SMD forces. Then when we we pull the DNA outside toward x-axis, then gradually the free energy starts changing.
So does that mean if you look at this graph, right, where right now, it looks like the free energy are the same for both at the 26 angstrom. Does that mean there, as far as I know that when the free energy minimum, the system is stable there, right?
Yeah.
So you mean like these two complex I and IIIT, so whatever these two complex are stable at that angstrom?
Yeah. Yeah.
Okay.
Yes. This complex free is, yes, what you said is correct at the beginning. Then we see that in I cannot see here, show here. after 20, about 30 angstrom, there is the significant difference, the free energy between these two systems.
Right.
Okay, good. Thank you, Rajat.
Thanks.
Any more questions? In the picture that the disease people, is this specific to methyl damage problem or it's general?
It is cancer disease problem only.
Okay, so not specifically this methyl damage, cancer due to methyl damage. We don't know that. Okay. Okay. Any more questions? Thank you very much, Rajanji. Very good talk. So I think we are at the end of the talks in this session. I would like to thank everyone, participants, our Kamalji, and everyone who helped while my computer frozen here. Sorry for inconvenience. So we had nice talks this afternoon. So I hope this will continue and get better next year. So I would finally like to thank again to ANPA for organizing this great event. Thank you very much. So I think after that, we may, this session will end, yes.
Yeah. Okay, I'll then in the session, I'll also like to thank every participant. Our biophysics growing, though it is small, but growing every year. I'm very happy to see a lot of biophysics people here in this platform.
Right, this is really great starting this year. So yeah, it will grow bigger. And so it brings us from around the world. So a lot of us didn't know before. It's a great thing, yes.
Any comments, Soma sir and Krishnaji?
Yeah, the only thing I would say is a thank you for everyone for making this a success. Without everybody's contribution, it's not going to happen. So thank you for accepting the invitations and helping throughout the process. Yeah.
Thank you. Great for biophysics.
Next year.
We'll definitely keep in touch to share science as well as societal. I learned today that the physics can also explain societal things. So
I try.
Okay.
Yeah.
All right.
All right. So
bye everyone.
Yeah. Bye. See you.
Bye everyone.
Okay, bye. Yeah.
See you. Thank you. So Kamalji, okay.